All right, that brings us to what is Apache Cassandra. Apache Cassandra is a fast distributed database built for high availability and linear scalability. We want to be able to get predictable performance out of our database. That means that we can guarantee SLA, a very, very low latency. We know that as our cluster scales up, we're going to have the same performance whether it's 5 nodes or 10 nodes or 1,000 nodes. We know that we're not going to have any single points of failure. One of the great things about Cassandra is that it's a peer-to-peer technology. So there's no master slave, there's no failover, there's no leader election, there's none of this funny business that we really have to worry about anymore. Out of the box, with open source, we can do multi-DC. When we're talking high availability, we want to be able to withstand failure of an entire data center. Cassandra can do that. You absolutely are not going to get that out of a relational database. We also want to deploy everything in commodity hardware. We talked about how expensive it is to scale things up vertically. With Cassandra, you're going to put it on cheap hardware, and you're just going to use a whole bunch of it. It's really, really easy to manage. And speaking of management, it's extremely easy to manage operationally. You can take the same 3-man team and have them manage a 3-node cluster or a 30-node cluster or a 100-node cluster. I have put this into production with that size team, and it absolutely works. One thing to keep in mind, it is not a drop-in replacement for a relational database. So you're not going to take the same data model and just throw it in Cassandra and hope it works. You are going to have to design your application around Cassandra's data modeling rules, but the net result is an application that will never go down.
If you want to think about Cassandra conceptually, you can think about it as a giant hash ring where all nodes in the cluster are equal. So when I say nodes, I basically mean virtual machines, or machines could actually be physical computers, all participating in a cluster, all equal. And each node owns a range of hashes, so like a bucket of hashes. And when you define a data model in Cassandra, and we won't be talking too much about CQL in this video, but when you define a data model in Cassandra, when you create a table, one of the things that you specify is a primary key. And part of that primary key is something called the partition key. And the partition key is what's actually used when you insert data into Cassandra. The value of that partition key is run through a consistent hashing function. And depending on the output, we can figure out which bucket or which range of hashes that value fits into, and thus which node we need to go talk to actually distribute the data around the cluster. The other cool thing about Cassandra is that data is replicated to multiple servers, and that all of those servers, all of them are equal. So like John mentioned when we were just talking on the previous slide, there's none of this master slave, there's no zookeeper, there's no config servers. All nodes are equal. Any node in the cluster can service any given read or write request for the cluster.
Okay. Let's talk about trade-offs. One of the things that's really important to understand when looking at a database is how the CAP theorem works. So the CAP theorem says that during a network partition, which basically means when computers can't talk to each other, either between data centers or on a single network, that you can either choose consistency, or actually you can't get consistency, or you can get high availability. So really what happens here is if two machines can't talk and you do a write to them and you have to be completely consistent, they can't talk to each other, the system is going to appear as if it's down. So if we give up consistency, that means we can be highly available. So that's what Cassandra chooses. It chooses to be highly available in a network partition as opposed to being down. In a lot of applications, this is definitely way better than downtime. Another thing that we need to know is from data center to data center, let's say we were to take 3 data centers around the world, maybe one in the US, one in Europe, one in Asia, it's completely impractical to try and be consistent across data centers. We want to asynchronously replicate our data from one DC to another because it just takes way too long for data to travel from the US to Asia. We're limited by the speed of light here. This is something that we are never going to get around. It's just not going to happen. That's why we choose availability, and that's how consistency is affected.
Now we want to talk about some of the dials that Cassandra puts into your hands as a developer to kind of control this idea of fault tolerance. So John talked about the CAP theorem earlier, this idea of being maybe more consistent or being more available. It's kind of a sliding scale, and Cassandra doesn't impose one model on you. You get a couple of dials that you get to turn to configure this idea of being more consistent or more available. So the first one we want to talk about is replication. So replication, usually this is called replication factor. It's abbreviated as RF. You'll see that a lot when you're looking at Cassandra documentation and whatnot. And a very typical replication factor for people running in production is a replication factor of 3. And essentially all this means is how many copies of each piece of data should there be in your cluster. So when I do a write to Cassandra, you can see in this example on the slide here, client's writing A, the A node gets a copy, the B node gets a copy, and the C node there also gets a copy. So 3 copies total for an RF of 3. Data is always replicated in Cassandra. So we're going to talk on the next slide about consistency level. Data is always replicated in Cassandra. You set this replication factor when you configure a key space, which in Cassandra is essentially a collection of tables. It's very similar to a schema in Oracle or a database in MySQL or Microsoft SQL Server. This replication happens asynchronously, and if a machine is down while this replication is supposed to go on, whatever node you happen to be talking to is going to save what's called a hint, and Cassandra uses something called hinted handoffs to be able to replay when that node comes back up and rejoins the cluster, to be able to replay all of the writes that node that was down missed. The other dial that Cassandra gives you as a developer is something called consistency level. So you get to set this on any given read or write request that you do as a developer from your application talking to Cassandra. So I'm going to show you an example of 2 of the most popular consistency levels with the hope that that'll kind of illustrate exactly what consistency level means. But basically a consistency level means how many replicas do I need to hear when I do a read or a write before that read or that write is considered successful. So if I'm doing a read, how many replicas do I need to hear from before Cassandra gives the data back to the client? Or if I'm doing a write, how many replicas need to say, yep, we got your data, we've written it to disk, before Cassandra replies to the client and says, yep, got your data. So the 2 most popular consistency levels are consistency level of 1, which, like the name sort of implies, just means 1 replica. So you can see that first example there, client is writing A to the cluster, the A node gets its copy, and since we're writing at consistency level of 1, we can acknowledge right back to the client immediately, yep, we got the data. The dashed lines on that diagram there are there to indicate to you that just because you write with a consistency level of 1 doesn't mean that Cassandra is not going to honor your replication factors still. Now, the other most popular consistency level that people use a lot is quorum. So quorum, if you've never heard the term before, essentially means a majority of replicas. So in the case of replication factor of 3, this is 2 out of 3 for 51% or greater. So in this example, again, we got a client writing A again, and you can see the A node gets a copy, the B node gets a copy and responds. And at that point, once we've got 2 out of the 3 replicas that have acknowledged, we can acknowledge back to the client, yes, we've got your data. Now, again, dashed line indicates that we're still going to honor your replication factor. We're just not waiting on that extra node to reply before we acknowledge back to the client. And you might say, well, why would I pick one consistency level versus another? What kind of impact is it going to have? Well, one pretty obvious one, if you think about it, is how fast you can read and write data is definitely going to be impacted by what consistency level you use. So if I'm using a lower consistency level, like say 1, if I'm only waiting on a single server, I'm going to be able to read and write data really, really quickly. Whereas if I'm using a higher consistency level, I'm going to be much slower to read and write data. Now, the other thing that you kind of have to keep in mind with consistency level is this is also going to impact your availability. So John talked about the CAP theorem and talked about C versus A and how it's kind of a sliding scale. Well, if I choose a higher consistency level where I have to hear from more nodes, where more nodes have to be online to be able to acknowledge reads and writes, then I'm going to be less available. I'm going to be less tolerant to nodes going down. Whereas if I choose a lower consistency level, like 1, I'm going to be much more highly available. I'm going to be able to withstand, in this example here with an RF of 3, I'm going to be able to withstand 2 nodes going down and still be able to do reads and writes in my cluster. And Cassandra lets you pick this for every query you do. So it's not going to impose one model. You as a developer get to choose which consistency level is appropriate for which parts of your application.
One of the great things about Cassandra, because we get asynchronous replication, is that it's really easy to do multiple data centers. So when we do a write to a single data center, we can specify our consistency level. Maybe we say 1 or quorum. If we're doing multiple data centers, we're going to say local 1 or local quorum. Now when that happens, you get your write, and it happens in your local data center, and then it returns to the client. And then let's say you had 5 data centers. The information that you wrote to your first data center is going to be asynchronously replicated to the other data centers around the world. This is very, very powerful. This is how you can get super, super high availability even when an entire data center goes down. So you can specify the replication factor per key space. So you can have one key space that has 5 replicas, one that has 3, one that has 1. It's completely up to you and completely configurable. It's important to understand that a data center can be logical or physical. One of the things that's great about Cassandra is that you can run it with a tool like Spark. And if you're doing that, you may want to have one data center, which is your OLTP, you're serving your fast reads to your application, and then one data center virtually that's serving your OLAP queries. And then doing that, you can make sure that your OLAP queries don't impact your OLTP stuff.